Okay, everyone, welcome back to our statistics class notes. And we're starting section 9.4, our very last section of the class. And we're in chapter 9 about doing inferential statistics or doing inferential statistics about population mean. So in section 9.3, we learned how to conduct how to construct a confidence interval for a population mean. Now we want to, in section 9.4, learn how to conduct a hypothesis test for a population mean. So remember, there are 4 steps for doing hypothesis testing. That's hypothesize, prepare, compute to compare, and interpret. In the hypothesize steps, we want to state our null and alternative hypotheses about the population parameter. In step 2, we want to do our preparations, which essentially means check the conditions of the appropriate version of the central limit theorem. So we're doing hypothesis test for means. We're going to check the central limit theorem for means, and also choose our significance level, alpha. Remember, alpha is the small chance that we're willing to take of rejecting HO, what we assume to be true about the population mean, when in fact it actually is true. And then third step, we want to do our computation. So we compute to compare. That's where we find the appropriate test statistic and its associated p-value. And then the p-value will be the actual risk we're taking of rejecting HO. And so then when it's actually true. And so we'll compare that p-value to the significance level. And if the p-value is less than alpha, we'll reject HO. And if it's greater than alpha, we will not have enough evidence to reject HO. And then we'll do our interpret. Do we reject that? So I was thinking about it up here. We actually state it here in the interpretation phase. Do we reject it, and what does it mean? So if we can reject HO, that means there is enough evidence to support HA. If we cannot reject HO, there is not enough evidence to support HA, the alternative. So a little bit before we do an example, the hypothesis test and what's the test statistic. So the test statistic is now a t. It's not z anymore. So it's t, which is x bar, the sample mean, minus mu naught, which is what we're going to assume is the population mean in our null hypothesis, divided by the standard error estimate. And the standard error estimate is the sample standard deviation divided by the square root of n. If the conditions for the central limit theorem for means hold, the test statistic follows a t-distribution with the degree of freedom being n minus 1. So we talked about that t-distribution. Just remember, it's very similar to a normal. It's just that depending on the sample size, so each sample size has a different number of degrees of freedom, it looks slightly different than the normal. It just has whether it has thicker tails or not. And note, the third condition when we're checking the central limit theorem, big population does not need to hold for a hypothesis test. So the only conditions we need to check are the first two, which is a random and independent sample, and then whether there's a large sample, which means either the population is normal already, and don't worry about the size, or the sample size is at least 25 if we're not understanding or know how the population is distributed.